Thank you very much. Hello, everyone. So this morning, our colleagues revealed some important road safety issues and challenges in the new decade. However, what about the past decade? Was there any progress? What are the gaps that we should fill to avoid similar problems within the new decade, especially in developing countries, which registered the highest numbers of fatalities? So as you can see on the screen, our topic is about crash data reporting systems in 14 Arab countries. We are going to define the most of the challenges and propose some areas of improvement. So I'll stick with the classical content required by the organizers. So back to March 2010, the United Nations proclaimed the Decade of Action, as we all know, aiming to reduce 50% of road crash fatalities by 2020. However, in the Arab region, instead of decreasing, road crash fatalities increased by 4%. So this negative performance could be explained by the quality of inputs, which may affect the output, like policies, strategies, and interventions. And also, there is several studies that affirmed that the regional the Arab regions suffers from multiple problems like credibility, accuracy, and completeness, especially because data is collected through manual reporting systems. Yes, we still have manual reporting system in 2020. Besides the difficulty of comparability between countries, because the data sets are very different from a country to another, which make the comparisons very difficult, and of course, which make the allocation of resources also very difficult. So the purpose of this presentation is to define and quantify the challenges by examining the actual crash data reporting systems in this region. And then we will propose two remedies, one in terms of selection of a common set of variables, and then by proposing a cost-effective solution to switch from manual to electronic recording. So to achieve the objective listed in the previous slide, we used the common crash data sets list of variables to assess the variables collected by the Arab region as a first step. And then we used the FARS data set to select the explanatory variables, the most explanatory variables of the severity. So for this, we have two steps. First, we selected some reduced data sets based on correlation, information gain, or gain ratio. And then to compare these three subsets, we applied some classifiers, and we compared them. So we will see later their results. And finally, the selected variables were inserted in our proposed customized e-form. So let's see the results. We sent a survey to the focal points of 18 Arab countries, members of the UN ESCWA, which is the Economic and Social Commission of Western Asia, which is equivalent to UNECE in Europe. And as a result, we got responses from 14 Arab countries, from North Africa, Gulf countries, and also Middle East countries. So as a result, the first result is about the dysfunctions at the management level. We assessed 4 possible entities that might exist and contribute on road safety in each of the countries. So the first one is the committee. Only 7 countries do have a national committee. But what is interesting that this committee doesn't involve the Ministry of Communication, which may explain why road safety issues are not promoted properly in the Arab region. Then the Higher Council, only 8 countries do have a council. And then the National Observatory, only 2 countries do have a national observatory, which may explain why the collected so poor. And for the National Lead Agency, we have 4 countries which have a lead agency, but even the functions of these lead agencies are not all verified. Let's move to the some examples of the data dysfunctions. So we still have heterogeneous definitions, especially for deaths and serious injuries. As you can see, multiple possibilities. If we take, for example, for Syria, we still consider only people who died on the crash scene as a death resulting from crash accident, which may lead to an under-reporting. Or, for example, for Jordan, we consider every person who is hospitalized as a severe injury, even if he enter and get out from the hospital within the same hour. So it may lead to an over-reporting. We have also a problem of using non-standardized values for qualitative variables. For example, collision type. We still not in Palestine and Sudan. We don't consider hitting an obstacle as a type of collision. Also, concerning all involved persons categorization, we still not make difference between rear and front passengers in many countries. Even Jordan doesn't take into consideration the cyclist as a possible value of road user. Plus the problem of locations, we still not have a big number of countries who is using the XY for the collision, which is very important for us for making the hotspot analysis, for example. Then we assessed also all the variables which are labeled as high important within the CADAS, and we asked them if they have these variables. We can see that we have a lot of light gray color, so it means that this variable is absent. Also for vehicle, yeah, don't have much time to see it all. And also for the assessment of the flow chart or data flow. Only 2 countries to have an electronic form, and the rest they are using paper forms. And also when it comes to the storage of data, we have different types of database and structure, so it's very difficult to merge them to make comparisons. Let's move now to the remedies. As I said before, we had used the first data set table, which is described here, to select the explanatory variables that explain better the severity, which is the class here. We have binary classification for crash and vehicle, and the multi-classification for the user. And then, after getting these reduced data sets, we compared them using multiple classifiers, naive Bayes, some decision trees, algorithms, also random trees, random forests, etc. And then we compare them based on the area under rock curve and the accuracy, both. When this AUC is greater than 0.8, this is considered as excellent. So after getting this final list, we added some variables from CADAS, because we needed also some descriptive variables, not only the explanatory variables, to keep traceability and to share responsibility, like names and make and this type of IDs. So we have here a list, a hybrid list. C means that from CADAS, and F means from FARS. After that, we inserted our list of variables in a prototype e-form, because during the survey, some countries expressed their inability to use internet in the crash scene location. So we needed another tool that help us to get the location and all the information with the built-in GPS, like from the mobile, without using internet. And for this, we got inspired from tracking animals in South Africa. So we find a tool called the Cyber Tracker, which is very easy to be customized. And it has many advantages. So it helped to have a synchronized data transfer when the investigator arrived to the police office, whether if via cable or secured intranet, and all the information still registered from the crash spot. Then he can make queries and visualize data within a built-in GIS capability. He can also make transfers and to make links with the server databases like SQL or online databases like it. So in conclusion, this study is the first step toward achieving a regional vision of the UN ESQA of establishing a Arab Road Safety Observatory aiming to present regional guidance and to facilitate regional comparisons, especially because these countries don't have national road safety observatories. And this paper investigated some data issues. We found many issues in terms of dysfunctions at the management and data levels. To remedy some of them, we used data mining techniques to select a common set of variables, and then to switch from manual to electronic reporting. We don't need big investment to build new e-forms from scratch. Getting inspired from other fields is also a key to improve road safety in developing countries. So thank you for your attention.